All right, let's start the show. Huh? This show. All right, we're going to do the distance formula. Okay, yesterday, like I said, you were supposed to do an Ed puzzle, which is in your email and it's in the chat. So do it in your own time, please. Just do it. All right, so the distance formula is this. It's D for distance. You should be writing this down. Is the square root, and make your square root extra long. And then we're going to be doing parentheses. We're going to be combining two parentheses that are squared. Okay? And the formula is this. We do x2 minus x1. Where have you seen that before? Where have you seen that before? On slope. Okay? You've seen this in slope because this has to do with graphing. And the distance between 2 points are usually going to make a diagonal, which is the C part of your formula. So this is the formula right there. The distance is usually the C. Okay, so that is usually, not always, usually the C. Okay? Almost like 99% of the time. So usually this is the formula that we've been dealing with so far. A squared plus B squared equals C squared. Okay? Well, let's put the C on the other side. That way it looks like that one. Okay, so how do you get rid of a square? What's the opposite of squaring something? There you go. Good old Diego got it right. So you do the square root of this and you do the square root of this side also. So that would give you C equals the square root of A squared plus B squared. And this right here is the same thing as all this mess right here. Okay? So we're going to call this whole thing A right here, and all that is B. So it's the same thing. This whole thing would be A. Remember, the x2 minus x1, all that is finding your horizontal distance. Okay? That is your change in x. Let me make some room here. This is your change in x, because remember, it goes side to side. If you go to the left, it's a negative. If you go to the right, it's a positive. Okay? So we're just trying to find out how far apart those two x's are. And then this right here, this is your change in y. This is your vertical distance. So we're trying to see the distance between the two y's, because we're going to have two y's and two x's. So that's all we're doing. Okay, so it's the same exact formula, except now we're doing it on a graph. All right, so let's do it on a graph. Where is my graph? Ready? All right. So here is my graph. Am I like super off center on Zoom? Who knows? All right, no we're not. All right, let's say we're going to keep it simple. We're going to do 1 point right here. And let's say 1 point, I don't know, right there. Okay? First thing we got to review is how the heck do we find out coordinates? Okay? Remember, to find coordinates, you have your x and your y. X, again, is your horizontal change, negative to the left, positive to the right. Y is your vertical change. If we go up, we're positive. If we're going down, we're going negative. Okay? We always start at the origin. The origin is right here in the center. And then we try to get to that point. First, we got to go side to side. So if I go this way, I go 1 over. So that means my x is a 1. And then to get to the orange point, I have to go up 2 jumps. So that's a positive 2. So that's the coordinates for that first point. 1 positive, 2 positive. So now let's get rid of this because we need to get to the other point. So we need to get over here now. So again, we're going to start way over here at the origin. And we're going to jump 1, 2, 3, 4, 5, 6 spaces to the right. So if I go to the right, again, that's a positive. So that's a positive 6. And then from here, I got to go up 1, 2, 3, 4, 5. And I go up, so that's a positive, so there's my coordinate. Okay, so now I know my two coordinates. I got a 1, 2 for this point right here, and a 6, 5 for this point right here. Okay, so now I know my two coordinates. So now, we're going to show you two different ways of solving the distance. Okay, the first way is going to be a lot more familiar, and the second way is going to be with the formula. Okay? So we're going to draw the lines. We're going to make a triangle because we've been dealing with triangles on every one of these problems. All these Pythagorean theorems are what kind of triangles? Right triangles, right? So that's what we're going to make. So I'm going to go ahead and connect these 2 points right here And that's going to be my C. That's what we're looking for. Okay, so if you want to put C right there, put C right there. Now we're going to do the other two lines, the A and the B, and we're going to draw them ourselves because they're not given to us. So I'm going to go ahead and draw it right there. That can be A or B, so I'm just going to call it A. And this right here can be my B. And if you want, you can even draw your little right triangle. So now we have a triangle, okay? We have an A, a B, and a C. Now this method, when you actually have a graph, it's super easy because you're already familiar with it. All you have to do is know how to count. What's the formula again?
A squared plus B squared equals
A squared plus B squared equals C squared. Okay, so let's color code the heck out of this thing. So A squared plus B squared equals C squared. Okay, so pink with pink, green with green, orange with orange. Okay? So all we have to do is count. How many spaces is A? How big is A? Well, let's count the squares. 1, 2, 3, 4, 5. So my A is a 5. So I'm going to put 5 squared. Alright, now we're going to do the B. How big is B? 1, 2, 3. So we're going to put a 3 squared. And then the C, we can't really count because they're going at a diagonal. I can't just count the squares. I can't just go 1, 2, 3, 4, 5, 6. I can't. Okay, that doesn't make any sense. Because distance is measured from one block to the next. So we can't do that on a diagonal. So we're just going to keep that as C squared. Okay? So now we're just going to square things. So 5 squared, 5 times 5 is 25. 3 times 3 is 9. And C squared stays C squared. Okay? So now we're going to add these two. What's 25 plus 9? What's 25 plus 9, kids? 24? So I'm going to do 24 equals C squared. Okay? And now how do we get rid of squaring things? What's the opposite of squaring? Diego, what's the opposite of squaring? Uy, ya se le pagó el poco. So we're going to square root this side right here, and somebody with a calculator? Let's go ahead and do this. So what's the square root of 24?
Mister, it's not 24. 34.
Oh, it's 34. Come on, kids. Who told me 30? Who told me 24?
He said 34. You heard 24.
Oh, okay. All right, so the square root of 34. What's the square root of 34? Like 5 point something?
Yeah. 5.83.
5.83? All right, so 5.83 and then dot, dot, dot in case it continues. And there, that's how you find it. Okay, so that's the easy way of doing it right here on a graph. But sometimes they won't give you a graph, okay? So that's when we have to use the formula. So we're going to go ahead and use the formula over here, and I'm going to use these same 2 points. And I'm just going to pretend we don't have it, okay? So again, the formula for distance is D equals, let me see if I'm on, yes. D equals the square root, okay? And then we're going to do x2 minus x1. So let me do this. Let me just set it up first, kids. There we go. All right, so we're going to do x2 minus x1. Hold on. Let's color code it again. Okay? And on the other one, this is the B, remember. This is A, this is B. We're going to do y2 minus y1. Okay? So because we have x2 and x1 and y2 and y1, we're going to have to label these right here. So this one right here can be the first point. So this is going to be my x number 1 in green and y number 1. And this over here will be my x number 2 and y number 2 in pink. Okay? So now we're just going to set it up again, except now we're going to replace all those variables with what they're worth. So let's go ahead and set this up again. And let's put the numbers where they go. So my x2 is right here, it's a 6, so that's going to go right there. My x1 is right here, it's a 1, so that goes there. My y2 is over here, it's a 5 in pink. And my y1 is going to be a 2 in green right there. Okay? So now I have everything set up, so now we can just start solving it. So let's go ahead and start solving it. So now I have d equals parentheses. And let's just put a number squared and another number squared. So I'm going to do 6 minus 1, which is 5. So this time I can just use black for everything. And 5 minus 2 is 3. Okay? And if you look over here, it's almost the same exact thing as this step over here. We have the same numbers. We have 5 squared plus 3 squared. Okay? So it's the same thing. All right, so let's do it. 25 squared, or 5 squared is 25. And 3 squared is 9. 25 plus 9 is 34. And again, we're at the same spot now. Look, we're here and we're here. Okay, it's the same thing. So the distance is going to be the same answer. So distance equals 5.83. Okay? So it's pretty much the same process, except here we're square rooting the whole thing right away instead of just leaving it squared and having to do it at the very end. It's just square rooted all the way through. So all you have to do is worry about making sure that you label these correctly and put them in the right spot. And then you can use the formula, or if you're on a graph, if you have a graph available, then just do it this way because it's a lot easier. It's a lot more familiar. All right, so that's how you do the distance formula with and without a graph.